start this ASO question part, guys. So again, guys, welcome to IGC. So we'll be solving 2018 ASO Aeronautical Engineering paper question. So around 6 questions are there, 5, 6 questions, and 2 questions from SOM, 1 questions from this aircraft structure component, and then one question from aircraft material and one from fatigue loading. So read this question number 37. What it says: in an airplane, fuselage, the stiffeners, what stiffeners do, are helpful in preventing buckling, are helpful in supporting lateral loads, cannot prevent buckling, cannot support longitudinal loads. So what actually stiffeners do? What is the
They
role of
provide structural
stiffeners in
support.
fuselage? It is helpful in preventing buckling. Okay, clear? Lateral loads actually supported by skin, and then those lateral loads will be transmitted to or redistributed to bulkhead and longerons. Okay, so mainly the major role is what helpful in preventing buckling. Clear? There is no cannot support longitudinal load. So actually this question should be more clear, because if you take there will be longitudinal stresses, right, due to pressure loading. Clear, guys? And those longitudinal or axial stresses will be what? Will be supported, yes or no, guys?
Yes, sir.
Supported, right? But again, this is not a MSQ, right? It's a MCQ question paper, yes or no? So A is the most appropriate answer, but D can be also correct, right?
Yes, sir.
No, D is not correct, because can
Sorry,
support.
that's not correct, sir. They can
Yeah.
support longitudinal loads.
Yes. So correct. So A is the only correct answer. Okay. And lateral load, anyway, aerodynamics load acting on fuselage are carried by skin. Okay. So next question. Yeah. So this question also we have done in last class, but we can see here, at a particular point in a structural member, a two-dimensional stress system exists where sigma x, sigma y, and tau xy values are given. If Young's modulus E equal to 2 lakh Newton per mm square, Poisson's ratio is 0.3. What is the shear modulus? So guys, here we know what is the shear modulus G from basic elasticity. It is E upon 2 into 1 plus nu. Now guys, just using this formula we can get answer. For what reason these are given? Sigma x and sigma y and tau xy, anybody? For what reason they have given this?
Confusing, sir.
And thus just for beauty of the question. Okay, yes, Ajay. Just to make question more beautiful, they have given. Okay, nothing more. So find the answer G, guys. We have done in last class. So it is 2 lakh upon, it is 2 lakh 2 4 5 6. Okay, upon 2 into 1 plus 0.3. So it is basically how much? 2 lakh divided by 2.6. Okay, 2 2.6. So how much we get? We get 76923 3 Newton per. Clear? This is clear, yes or no, guys? Check this calculation, guys.
Yes, sir. Yes, sir.
So what is E? Modulus of elasticity. What is nu? Poisson's ratio. G is shear modulus. Now guys, you guys don't just remember this. Now I'm asking one more thing. In this question, if they ask find out bulk modulus, okay, Mr. Uttam, what is the bulk modulus? K. What is the bulk modulus? K?
9 kg by 3 into k plus c, sir.
Huh? In simple word, you can tell K in terms of E and nu. How much it is? Hmm? It is E upon 3 into 1 minus 2 nu. Am I correct?
Yes.
Right. So if K is asked, then what will be your answer? So it is 2 lakh upon 1.2. So what will be answer? Now guys, I am asking further one question. When your solid will be perfectly incompressible, when your solid will be perfectly incompressible, for what value of K? Debanjali, Uttam, Ajay, Praniti, when your solid will be perfectly incompressible,
Value of K will be infinite.
value of K is infinite. When value of the K will be infinite?
When the
Poisson ratio is
volumetric
0.
strain is zero.
Poisson ratio is 0.
No, volumetric strain is zero.
If Poisson's ratio is 0.5,
0.5, yeah.
then your solid will be perfectly incompressible. Okay, so this is one of the gate question from gate mechanical. For a perfectly incompressible solid, what is the Poisson's ratio? So what it is? 0.5.
0.5.
So many questions we can understand from a single question. Clear? Or a concept. So volumetric strain will be 0 and your Poisson's ratio will be 0.5. Okay. Now what is the limit for Poisson's ratio? Can anybody tell? For any material, what is the Poisson's ratio? The range
-1 to 0.5.
minus,
1 to 0.5.
yes, -1 to 0.5. Now
0.5,
tell
yeah.
me why Poisson's ratio cannot be lesser than -1? Why Poisson's ratio cannot be lesser than -1? Can anybody? Okay. So what is your G? G is E upon 2 into 1 plus nu. What is the K? K is E upon 3 into 1 minus 2 nu. Now guys, if your nu is lesser than -1, what is going to happen? What is going to happen? Anybody can tell? G
G
will
will
become
come
what? Negative, which is not correct. Now,
Possible.
if
These terms be
not
positive.
possible, Yeah, G must be positive always. What about nu? If nu is greater than zero point 0.5, what is going to happen?
Work modulus will
Yeah,
become negative also.
exactly, which is not correct. So that's why new value should be always lesser than zero point 0.5 and greater than -1. So your lower limit of Poisson's ratio is decided by G and upper limit is decided by K. Clear? Everybody, it is clear? Why new is always between -1 to zero point 0.5. Clear, everybody? Okay, so these things keep it in mind. May not be asked in ASO, but helpful if any related question. Now the next question, read: which type of the fatigue is caused due to vibrations excited by jet or propeller noise? So can anybody tell what actually this jet engine do? If you take aircraft engine or propeller, this aircraft propeller, at different section there will be different rpm excitation will be there. So those excitation, what they do to supporting component, they will carry some load. Okay, dynamic loads. So due to those dynamic loads, those supporting components will undergo what? Can anybody tell what kind of fatigue? Okay, first understand what is the fatigue. What is the fretting fatigue? Not acoustic. Not acoustic. Noise, propeller
The
noise, right? Yeah,
crack initiate. Sir, it
yeah,
becomes
yeah, yeah,
cracks are
yeah.
developed, sir.
It's a propeller noise, right? Jet or propeller noise, correct. I will tell. What is the fretting fatigue? Correct only answer,
Sir,
Praniti.
the crack propagation, I believe.
No, fretting fatigue is related with corrosion. What happened? There are some joints connected, right? So due to corrosion, the fatigue will induce is what? Fatigue. Okay, now cyclic fatigue. So cyclic fatigue is where, see, due to these engines, right, at different location you have different rpm of the engine. So these supporting components will undergo what? Some kind of excitation. No, it is not like that, Praniti. Uh, it is not like that. Okay, fatigue is related with corrosion. Cyclic fatigue is related with excitation, oscillatory excitation. Mainly in aircraft engine, the supporting components will undergo excitation due to engine. So there is called something called HCF, high cycle fatigue. Okay, so high cycle fatigue comes under cyclic fatigue. Dynamic fatigue actually is related with what? When your structure is subjected to some environmental condition. Okay, yeah, wear and tear. No, corrosion also, it is just like wear and see, wear and tear happens due to corrosions. Okay, when there may be some gap happens between joints, or you can say two components are joined. If corrosion happens in one component, your that area na where two surfaces are in contact area will become lesser. So then fatigue happen. Okay, so dynamic fatigue mainly happens when your any system exposed to environment like sunlight, okay, moisture and all. Acoustic failure is related to noise excitation. Clear? So what is the answer? In this case, they mention propeller noise or jet noise. So what kind of fatigue is acoustic fatigue? So D is the correct answer. D is the correct answer. Yeah. Devanjali, you want to say something?
No, no.
Okay, fine. So, guys, what I suggest, in aircraft industry, fatigue is very very important. Okay, and in aerospace engineering, we don't study. Where we study fatigue mainly. In our aerospace engineering syllabus, fatigue is not there in syllabus in BTech level. Guys, fatigue is mainly studied in machine design. Okay, in machine design syllabus. What I am going to do, I'll share, some of, I think or two lecture of this fatigue. Okay, so you guys go through this fatigue. They may ask some questions on minor rule, uh, then the some questions on stress ratio, the questions on alternating stress finding. Getting my point? They may ask some question, okay, on what is low cycle fatigue, high cycle fatigue. Okay, so that you guys should read it. Okay, because it's a part of aircraft structures if you work in industry. Clear my point? You guys can do, right? I'll provide input. Okay. Now the next question. Read. Which type of steel is used to manufacture aircraft arrestor hooks? Tell me, guys. It's straightforward. Marazing steel, right? We have already seen during the theory. Okay, it's a C. Marazing steel. Yeah. So this is another numerical, simple numerical from SOM. A cylindrical pressure vessel has an internal diameter of 2 meter and is fabricated from plates 20 thick. If the pressure inside the vessel is 1.5 Newton per square, what is the longitudinal stress produced by internal pressure? So guys, tell me, in cylindrical pressure vessel, what kind of stresses induced due to pressure? We discussed, right? What those two stresses, can anybody tell? One will be circumferential or hoop stress, right? And another is
Yes.
what?
Axial or
Axial,
longitudinal?
longitudinal. So what is your circumferential or hoop stress?
PD
Diameter
by
is
40.
given, right? Exactly. It is PD by 2T.
40.
And what is your
2T.
longitudinal or axial? It is PD by
PD by
40.
40.
What is asked in your question? Axial is asked. Now everything is given, guys. So find out this stress, guys. So pressure is how much? Sigma axial or longitudinal is asked. So pressure is 1.5. What is the diameter? It is 2 meter. So we have to convert 2 meter to So it will be how much? 2000, and PD by 4T. T is how much? Thickness is 20 So what is the answer, guys? Hmm? What is the answer? 37.5. So what is the answer? Everybody, is it correct? 37.5 Newton per. Is it correct, Mr. Ajay? Okay. Now, guys, I am asking, if they ask answer in megapascal, what will be the answer?
Same.
Huh? What
37.5.
will, why?
1 megapascal is equals to
Yes. So 1 megapascal is always equal to 1 Newton per
Newton per meter
mm
square.
square. Okay. So that's where important thing. Okay. So sometimes they ask answer in kilopascal also. So guys, don't worry. You first find the answer in Newton per mm square, then you can write megapascal. If asked answer in kilopascal, what it will be? Anybody? It is 37.5 into 10 to the power 3 kilopascal. Clear? So we can write like this. Okay. So then D is the answer. D is the answer for this question. Okay. So I think these many questions only asked from aircraft structures part. So guys, this time